This YouTube video, the related documentation given below, should allow you to duplicate my AS3935 based Lightning Detector prototype. I assembled all the components on a long wooden board that's about 14 inches long and about 3 inches wide. Up at the top is the TFT 4.0 microcontroller. Down at the bottom is the SparkFun Lightning Detector. And we want that lightning detector sensor to be about at least 6 inches away from the rest of the circuitry to avoid getting radio frequency interference. This is a close-up of the SparkFun sensor board. It contains an AS3935 lightning detector integrated circuit. It's set up for SPI interface. Here you can see the TFT wired onto the proto board and the breadboard. Here you can see the TFT, a close-up of it compared to a quarter. It's fairly small, but very powerful. This is a close-up of the Adafruit 2.2-inch color screen. It's 320 by 200 pixels. What you see here is all clear showing. If there's been no lightning strikes for 100 seconds, and you can change this, then you'll get an all clear. This should probably be longer, but while I was testing, I was impatient and didn't want to wait forever for an all clear signal to come through. Other TFT displays can be used. I just happened to pick this one because I had it floating around and it would accept 3.3 volts. This is what the LCD screen looks like after a lightning strike has been detected. We throw up the lightning detected message in red there. You also get a distance, which is the distance away to the center of the storm, and a indication of the lightning energy. It's a meaningless number, but it's just it's relative to the strength of the signal coming in. I also start a timer since the last strike was detected. Here it's showing 11 seconds. It'll go up to 100 and then reset to the all clear. However, that can be changed. You can set that a lot longer if you want. Also note on the second line you'll see the indication disturber. You'll get disturber indications if you get some kind of electrical interference or a lightning strike that didn't quite fit the pattern, the secret detection algorithm of the AS3935 lightning chip. And it's not uncommon to get disturbers. I think these happen on cloud-to-cloud lightning. And you will see these show up also while lightning is being detected. Also when the storms are very far away and fairly low level, you'll see disturbers starting to show up before you'll get a lightning bolt detected. Alright, so how well does this thing work in a real storm? This is an image of a large storm system that came through the upstate New York area. I live near Latham, and my brother actually recorded the lightning strikes and sent this over to me afterwards because I was sending him pictures of what my lightning detector was showing. So the next image you'll see is an actual recording of what the lightning detector is showing on the display during a portion of the storm. Alright, this is taken during the height of the storm, and every time that red LED above the display flashes, that's indication of a strike being detected. Now what's happening here is the strikes are coming so fast and furious, the counter is not getting a chance to really go beyond a 1 second here because the lightning strikes are so frequent. You'll also see the disturber indications lit up, and you'll see the storm intensity and distance also showing up. The storm was further away than 1 kilometer. I got a bug in the software here I got to figure out. So it does work most of the time, but not all of the time. The next part of the circuitry I want to talk about is using a 74HC244 as a buffer to isolate the SPI bus between the most of the circuitry, the TFT display and TFT microprocessor, and the SparkFun lightning detector. This buffer is critical in keeping the SPI signals from interfering with the lightning detector. Also on the GitHub site, you'll find the schematic bill of materials and the code that I use for the Arduino IDE environment to compile all the software for this. There's a README file posted up there too, which has a written description of the circuit and some gotchas, also some hints and warnings and things like that. I had a great time doing this project. I want to finish fixing all the bugs, but I felt it was good enough to publish for now. If anybody's got any questions, I'll be glad to respond to those, or be interested to see if anybody has any improvements on this also. I hope to fix the bugs and get this thing all in a nice box, and so there'll be a part 2 of this eventually.